Hello, good morning, good afternoon, good evening, everyone, from whichever part of the world you've joined in from. Thank you for joining this webinar on this interesting topic of digital transformation with iEdge 360 platform and sharing your valuable time in order to listen to our webinar. I would like to notify to all the attendees that they will be on mute throughout the webinar session. If you have any questions, you can mail to us at contact@simcondigital.com or to me directly at ankush.bose@simcondigital.com. You can also follow our social media pages and you can write to us. And you can also visit our website and fill our contact us page, and we will revert back to you within 24 hours. So before we start the webinar and introduce our speakers, I wanted to give an overview of how edge computing is transforming the digital revolution. Often touted as the next big thing, many companies are wondering how edge computing differs from more traditional data processing solutions and how it could benefit their business. Gartner predicted that by 2025, 75% of enterprise generated data will be created outside of centralized data centers. So manufacturing organizations have shifted focus from the central data center to the logical edge of the infrastructure, taking storage and computing resources from the data center and moving those resources to the point where the data is generated. So what happens if the data is generated on the edge? Well, it improves the speed, scalability, security, and reliability. Today, our speakers will talk more about it in more details. Talking about our organization, CIMCON Digital. CIMCON Digital is a leading edge IoT machine anomaly detection and diagnostic platform and product solutions. We are a 33-year young and reputed organization with over 200 plus engineers and R&D teams, and have a proven track record of connecting assets in various industries, starting from manufacturing, energy and utilities, smart cities, smart water, smart buildings, and other industries all around the world. So let us introduce our speakers for today. Next slide, please. So my name is Ankush Bose, and I am the Director of Smart Water Business and Marketing for CIMCON Digital. We have our first speaker with us, Mr. Prashant Kapadia. He is the Chief Growth Officer at CIMCON Digital. He has 25 plus years of experience in industrial automation, Industry 4.0, and digital transformation. He's a thought leader, public speaker, and passionate about digital technologies. He has served prestigious organizations like GE Digital, Hitachi Vantara, and TCS in senior leadership positions. Next, we have Mr. Subrato Roy. Subrato is a Vice President Client Outcomes. He has 22 years of experience working in various domains such as telecom, transportation, smart cities, and smart buildings. As a professional, Mr. Subrato has held leadership roles in delivering embedded and IoT products and platforms and associated with big organizations like Collabora and Siemens in his professional career. Thank you for joining this webinar. I would like to discuss about the agenda in short before I hand over the presentation to Mr. Prashant. So these are the agenda on which our speakers will talk today. So we will talk about the challenges in digital transformation and how this Edge IoT platform can overcome those challenges. We will deep dive into the Edge IoT platform architecture and microservices catalog. And we will talk about how we can enable the system integrators and OEMs to participate in the digital economy. So without any delay, I would like to hand over the presentation to Mr. Prashant, who will take over from here.
Very good morning, good afternoon, and good evening to everyone, wherever you are in this world. And I would like to start this topic of digital transformation, enabling digital transformation, with a one question that, do you know what are the significant barriers in any transformation initiative? And it's lack of insight and foresight. And data is a very critical element for having a real-time insight and foresight and successful in the transformation initiative. And so with the digital transformation. And now digital transformation is much talk word, or not becoming buzzword. And people are saying very easily that data is a new oil, data is going to rule the economy in the next century. And in this context, I just want to compare oil economy with the data economy. And you all agree with me that extracting oil was also not very easy in early days, even not today. And you think countries and business had not invested in extracting those oil, had not invested into transporting those oil, and had not invested into refining those oil, could have built oil economy. And it was challenging to remember putting up the well into deep sea oil, cross-country pipeline, or putting up the refinery and technology in refinery to extract gold from that black oil was very, very challenging. And it's challenging to today also. But historically, businesses and countries who invested into these technologies and overcome these challenges rule the world. And I would say extracting this data and creating the insight and foresight from this data is also similar challenges. But good news this time is potential opportunity available from this insight and foresight to improve business efficiency, improve productivity, and creating differentiation is much, much larger. And people who have not invested he lost those opportunities. And if history repeats, I'm sure this time also people who invest will gain tremendous amount of benefit, and who do not will definitely will lose this golden opportunity. So now question comes, how to enable digital transformation? And as I told you, any transformation challenges are not easy, and digital transformation is also very complex, and it requires a lot of tools and technologies, change management, and many other areas to cover. But if you see the challenges, so whenever there is a transformation and digital transformation subject, challenges are mostly common across the industry. Data in silo, legacy system, and lack of real-time visibility. And it's not different for manufacturing industry. In manufacturing industry, people logging data into logbook, convert into Excel sheet, putting in a PLC system, putting in a DCS, historian, and life of machine is 20 to 5 years, and life of Windows is every 3 years, and life of mobile is every 6 months. So you have to deal with legacy system in your manufacturing floor. You have a legacy system and combination of new generation system. And lack of data and lack of connectivity with the legacy system will the reason for lack of real-time visibility. And when challenges are bigger and tough, current approaches will not work. You have to choose different approach. And I will show you what people are taking current approach and what are the pitfalls in this current approach and what should be the approach you should take in a true digital transformation journey, and data to be utilized for your transformation. So next slide. So these are our point of view on what you're losing if you are disconnected machine, and disconnected machine has a cost you cannot ignore. You have a strategic cost, losing reputation. If you are acting reactively, not proactively, and you have a downtime, and you are really could not able to serve your customer on time, you will lose not only reputation, but you will lose customers. Lost opportunities. Opportunity in manufacturing floor, window of opportunity is very, very small. If you do not have a visibility, you're operating blind, then definitely you will lose opportunity to improve efficiency, productivity. And inefficiency is the biggest cost in any business. And connected machines or connected factory has a tremendous opportunity to improve productivity, increase uptime, and or reduce defects, take or journey to achieve first time right, and reduce time to market. So taking into the next slide, where I want to show you how people are taking current approach, and current approach is not good enough. So these are the current approach people take. So digital transformation, most of the people start with a pilot project, and like they take the one use case and they collect the data, putting some converter on the machine, putting some protocol converter, and some kind of that. But you understand digital transformation is not a task or project to complete. It's a journey, and use cases will evolve as you progress forward. So you should, and you require same data in a different use cases. So you cannot take the short-term approach to collect the data for one use case and connect to the ERP, and then second use case, put another converter and connect to the MES or dashboarding. So that way you are creating another basically risk in your manufacturing floor or control system layer, which multiple failure point, and increase the risk of obsolescence, because all the devices you are putting have their own product life cycle. So you should have approach, very different approach, where you can build the sensor data lake, and all the devices you are putting as a converter, there is no compute. Okay, so actually you are putting lot of load on the central computing, rather people are taking edge computing or distributed computing, and you are multiple time pulling your control system, your machine, for the same data, which actually creating the overload or overhead on those control system also. So with all this risk in the current approach, I would say, what is the approach, right approach with the edge IoT platform? So you have a machine, you have a line, you have a plant, and any machine, you have certain data you are collecting from the PLC data acquisition system, certain data you to collect from the sensors, pressure transmitters, float meters, and those sensors are either 485, 420 milliamperes. Sometimes new generation sensors are connecting on a Wi-Fi, Bluetooth. So you have to think all these possibilities when now you choose your edge device. So edge device should capable to ingest data on the all type of possible communication. So today your use case may demand couple of data on 485 to 20 million. But tomorrow second use case required data on the Wi-Fi or Bluetooth. So you're not required to again go and connect some new kind of devices. And When you choose edge device should have enough capability to transform the data. And before transforming the data, because most of the plant environment are have an intermittent bandwidth issue. Internet is not a stable intermittent bandwidth. So you should have a functionality of store and forward. So you will not lose the data. You should also, this particular layer have also responsibility to check quality of the data, because sensors are always prone to fail, and you cannot send garbage data to your transformation layer, which is whether rule-based engine or AIML AIML model. So you should have a data quality and validation algorithm running on this layer. So only good data will go for the transformation layer, and transformation is a data transformation is very critical layer, where you require to transform the data either putting simple rules or using Python or some kind of language, flowchart based language like Node-RED, and only transfer the transformed data. So transformation near the machine is very critical for most of the use cases in manufacturing industry. And because manufacturing industry use cases are low latency use cases and demand real-time decision making. And now security is another concern, where if when you're sending the data to the cloud, even though standards are evolving, but having data on premises on an edge has certainly advantage of security, better security. So now Subrato will take you to the deep dive into this edge IoT platform of CIMCON called iEdge 360. What we are doing, we helping you to realize your digital potential by making financially viable solution, deliver faster rate of return, and helping you to execute multiple use cases and maximizing utilization of your data. So I will now request Subrato to take you deep dive into our i 360 architecture.
Yeah, so good morning, good afternoon, and good evening to all of our audiences joining all over the world. And thank you, Prashant, for setting the context for the edge computing platform in respect to the digital transformation for the manufacturing industries. So I will just go into a little bit more detail on what Prashant has already talked about. So let us move to the next slide immediately. So let us begin with what kind of infrastructure do we need in terms of digital transformation when the same is applied for a typical factory shop floor. So there are four major components that we will encounter when we set up an IoT-based digital transformation platform. We will encounter a lot of sensors on the factory floor. They could be smart sensors, they could be legacy sensors, or they could just be appliances. Then we'll also encounter something called the edge computing devices, which is the focus of this discussion. What does the edge computing device does? It provides a very important platform to host the sensors. In that sense, it's a very important bridge that is going to take the sensor data right from the factory floor onto the backend enterprise, whether it is in cloud or public infrastructure. It is transparent. Then a third piece of infrastructure that also comes into play are the network gateways. So network gateways are typically the piece of infrastructure that can connect to backend with a 24/7 availability using variety of networking resources. It could be an fiber optic cable. It could be just a GSM modem, ADSL from typically legacy telephone network, WiMAX, and the possibilities are many. Finally, the fourth part of the infrastructure is the enterprise backend. which is, as I mentioned, it could be on a public cloud or it could be a private cloud. And the purpose of this infrastructure is to hold the long-term data that we're collecting from the sensors. It also provides a centralized control over the sensors and the edge computing devices. It allows us to do very complex analytics because we have the data collected across the shop floor, across a very long timeline, and then these kind of data summaries can be used by user applications. We can generate notification, we can send out alerts, and of course, there are a lot of use cases wherein we can do data visualization and dashboards. So this is in a nutshell the four very important components of the IoT landscape when it comes to digital transformation. With this information, we can now deep dive into the second component in the architecture here, that is the edge computing part of the architecture. So which will be the focus of our discussion going forward. Let us go to the next slide. So in terms of a digital transformation journey, when we talk it in reference to an integrated IoT architecture, what are the key functions an edge device provides? So we can summarize the key function as follows. Primarily, an edge device is a sensor hub. It allows us to connect lots of equipment, whether they are smart sensors, legacy sensor. In factories, it could be traditional PLC devices. And of course, there are a lot of equipment that can be just connected over wires to read very simple mechanical and electrical readings. An important feature of a very good edge device, a well-designed edge device, is it can act as a vendor-agnostic interface to various equipment that we find on the shop floor. How is this possible? This is possible because an edge device should be able to support a lot of inbuilt industry standard protocol adapters. And in fact, what we have from CIMCON Digital is such a device. We have something like 20 plus industry standard protocol adapters, which allows us to connect the device to a variety of equipment, sensors, and machinery. A third function that an edge device can also perform is a gateway function. So if we look at the top end of the edge device market, IoT edge device market, in addition to being a sensor hub and data collection point, they can also directly connect to the backend cloud or enterprise network. In that sense, they also function as a gateway. So this kind of eliminates the need of a dedicated gateway device in the architecture. It simplifies the architecture a little bit. Telemetry processing. Also, this is a very important feature. What do we mean by telemetry processing? The data that we are collecting from the sensor. In IoT parlance or in IoT nomenclature, we call them the telemetry. So this is processed on the edge device. So what kind of processing do we expect on the edge device? So the sensor data that is collected, it can be normalized into same type of naming convention across various sensors coming from different vendors. The data can be converted to a similar type of measurement unit. Data can be enriched, and when we talk of enrichment, it means we know there is a that's some kind of data coming from a sensor. We also find out what is the registered device ID for that sensor, and then we can combine sensor data from multiple sources and create some kind of a combined payload. Further on, if we look at more advanced processing, we can also have certain summaries and advanced calculation on the basic telemetry data. So in nutshell, a lot of things can be done on the telemetry processing function itself. Scalability. Scalability is an important feature when we have a factory environment where the number of sensors are growing, number of machinery is growing. So as we add on number of devices, if we decide to have the processing done at the cloud itself, that calls for a vertical scalable model where we go on adding number of CPU resources, memory resources, storage. So as the number of devices grow, this is a very costly architecture because the requirement kind of grows in exponential fashion. Alternatively, this scalability can be achieved at the edge itself. How do we do it? We just go on adding more edge devices, and as the number of sensors and equipment grows. So this is a kind of a horizontal scalable model. And this grows in a linear fashion, very cost effective, very rapidly deployable. So this is an important feature that a edge device can provide to a IoT landscape. Finally, we also should look at what kind of intelligence an edge device can provide to an architecture. So as Prashant has previously mentioned, an edge device can run certain number of user-defined workflows. It can also have a set of rule engines that can act upon one or multiple type of sensor data to take an action. And then, since these edge devices also sometimes contain usable software development kit or APIs, end users can create their own intelligent application and deploy them on the device. So in that fashion, the edge device allows us to take some action right there at the shop floor without even going back to the cloud, and thereby reducing the round trip that is involved, and that allows us to perform a very low latency function at the shop floor itself. So with these key functions in mind, the edge device, we can move further into other aspect, like how does the architecture looks like when we take all these functions into mind. So let us go to the next slide. This is a typical industrial IoT edge platform. So we have taken a reference to CIMCON Digital's IES360 platform, the kind of functions it does. So we can summarize in a very basic block diagram the sensor data collection part. Then we have a lot of industrial assets that gets connected, and finally whatever assets we are able to connect to the edge platform, there is a connectivity part to the private or public cloud, which can come from industry vendors like Amazon AWS, Microsoft Azure, Google, or it can be a very kind of a private data center from the customer itself. A key component in this architecture is the edge management system, where this system can do further filtration, enrichment analysis, storage, and distribution. And like it can also manage the edge device fleet, perform remote update to the firmware. It can run workflows. It can host dashboards and visualization, basic user interface. And looking at the architecture, a final piece is the data lake, which Prashant has previously talked about, the sensor data. So data lake, the primary function is that we get to access the data collected by the sensors in an organized manner, which is nicely structured, labeled, grouped, so that the researchers or the data scientists or user application that are going to use the data are able to rapidly deploy end user application. So this is in a nutshell, and how and if I call an IoT stack looks like top to bottom, the edge platform, the sensors, the edge management, and the data lake. We can take another alternative look at this block. Continuing from the last slide, this is another view. This is more of a stacked view of the diagram, wherein we have more details into the individual blocks. So an edge device per se, it can connect to variety of equipment with dedicated peripheral data acquisition interfaces. So in an edge device, we can expect to have almost all the common industrial protocols that can communicate. And additionally, it should also communicate with very common industry-leading PLC equipment and machinery. So in a nutshell, this is my IoT edge device is a sensor hub. It's also an interface for various machineries. On the upper hand, it should also be able to talk to multiple types of edge management system. So typical protocols that we can expect this edge device to communicate with are MQTT, HTTP, XMPP, COP, and there are other protocols also. So this is just a list that we have in our device from CIMCON Digital. So as we move up in the diagram, the edge management system that we have just touched upon in the previous slide, how does it looks like? So yeah, this communicates with the device with all the 4 protocols depending on the scenario. And then the edge management system, after it has interacted with the device, it also interacts with the data lake, which is our destination for long-term telemetry storage. A typical data lake can be implemented using file storage, very large kind of NoSQL storages, or even some combination of RDBMS. What does the data lake do finally with the data after it is processed? It makes it available to interested consumers in various forms. So we might have machine learning applications that are creating machine learning models. There might be customized applications. There are data consumers, typically data scientists and researchers who just might need to look at the data. And there could be third-party dashboards also. How this data is exported out of the data lake? There are common protocols. MQTT we use to push out data. HTTP can be used to pull data out of the data lake. And there are some consumers who prefer to have file-based interface. And of course, finally, some of the data can be shared as network directories where someone can connect to the data lake and collect the data that they want to use on regular basis. So this is in nutshell is a stacked architecture of the previous diagram to have a more detailed view how each of the intervening components are coming together. We can move to the next slide. So this slide is a little bit more interesting in terms of like we have taken a look at the functional view of the integrated IoT architecture. And also we had a stacked view, look at the stacked view of the architecture top to bottom coming from sensor to the data lake. Now this is a closed loop architecture of the same that we have seen earlier. The purpose of this overview is to understand how does data actually works within a connected system and how the intelligence as it is gathered is made to perform in a much more refined manner at the edge device itself. So herein we can start with the edge device. The edge device, as it collects a lot of data from various sources, it has two execution paths. It can invoke a machine learning application, which we'll take a look later on, or it can just invoke the transport service, a transport adapter in the device to send the data directly to the edge management system. So we continue with the simple path. As soon as the edge management system gets the data from the device, what it does is to do some simple filtration and enrichment and puts the data into data lake. So data lake, as we have seen earlier, is a storage destination. It doesn't do much of processing on the data. In this diagram, it is the analytics part that makes maximum use of the data from the data lake or the telemetry storage. This is where we run our machine learning algorithms to train our machine learning models. What is the output of this machine learning models once they are trained? They can be used to drive some user applications. They can be used to drive some user dashboards. They can be independently used by third-party users to do some inference on their own data using our models. And finally, the most important, we can package this model, put them onto a repository, wherein such repository are also accessible by the edge device. So it works in a seamless fashion. The edge device regularly updates itself with whatever there is in the software repository, which includes machine learning models as trained earlier. Now we come to the second flow within the edge device. That is the sensor data going to a machine learning application. As we have seen, the machine learning application is able to get the latest machine learning models right from the repository. It is then possible for these applications to take the sensor data and run an inference against the model. This is where the intelligent aspect of the edge device comes into picture. It is able to run the model, get some analytical result, and put it to the transport for further transmission. So with this diagram, a key conclusion that we can draw, the edge device, in addition to an data collection platform, is also an intelligent device for local execution, local action, and advisory to the edge management system. With this diagram, let us also move to the next slide. We'll talk a little bit on the platform security. So we have seen like how exactly the data flow happens across various components in an integrated IoT platform. One aspect that is very important, and it is also very important from the customer point of view, is the security of the data. So how does the data security is handled in CIMCON's IS360 platform? Our IS360 edge device implements a 3-layer security with the edge management system. All the data is sent over a TLS socket, a TLS secured socket using a TCP connection, which means any connection that we make with the server from the device is over a TLS socket. How is the session secured? Once we have a TLS connection, each device is loaded with a X509 certificate, which is used to authenticate with the Edge Manager system. Again, these certificates are issued by the Edge Manager itself, which means we know once a device connects to us, it is our device because it is presenting itself to the Edge Manager with a certain pre-identified X509 certificate. Finally, when we collect the telemetry data, we tag the data with some device identification number. Again, the device identification numbers are something issued by the Edge Manager itself. So after we have validated ourselves with the Edge Manager in terms of the underlying connectivity, in terms of the session identification, we do make sure that the data that is being sent to the Edge Manager is actually tagged with something that the Edge Manager can recognize and come to a conclusion, yeah, this is coming from a validated source. So this is a 3-layered security. And then finally, what happens when the data is with the Edge Manager and it needs to talk to various internal components? Internal components like our data lake as well as our firmware ML model repository, they are secured behind corporate firewalls. So it's a very secured architecture. Data is made to follow certain norms and security checks to ensure it is not intercepted in between, it is not changed in between, and it is only accessed by those who are authorized to access this data. This is in brief what is our security architecture is. Let us quickly go to the next slide. A typical question that we always come across is, okay, we have seen the data flow diagram, we have seen the intelligent flow in a closed circuit loop, or the security. What does it looks like when we finally try to deploy this system, a bare minimum system with certain high availability assumption? So this is how it looks like. If we take a batch of edge devices, we expect to deploy an high availability MQTT proxy server, which can make sure the devices are able to consistently send the data. And then we might deploy a set of MQTT broker in a clustered manner that can talk to the proxy. Edge Manager systems in similar fashion, a clustered environment which sits over a network attached storage, so that at any point in time we have one or more node available for 24/7 operation. Similarly, the data lake can also have a clustered setup where data is also available for end consumers online around the clock. So this is a very minimal high availability architecture. Of course, as a number of devices grow and the computing needs grow, being a clustered setup, the number can actually be expanded. However, this will suffice in most use cases for a moderate computing needs. So you can just move to the next slide for some more details. Yeah, so we can summarize what kind of services this edge platform actually provides in a digital transformation journey. And these are the very important ones. So edge connectivity, as we talked of, it is basically the sensor hub feature for devices, sensors, equipments, and machinery. Edge control and command. So this is two-way. One is to have a control over the connected machinery and sensors. Second is the ability to control the edge device itself from an edge management system, which is very important. Edge intelligence that we have just touched upon and many times, ability to run some intelligence on the edge, either it is a predefined application or it is some kind of a machine learning model. Edge security, we just talked about. Scalable system, as being a lot of things being done on edge, we're able to scale as per our need in a horizontal manner. And purpose built microservices, which means a lot of services that are being capable of running on edge devices. For example, applications that do FFT calculation on acoustic and vibration data. There are applications which do analytics on video streams coming from IP camera, to give you some examples. So these are the 6 key features in terms of services, we can say, that the edge platform provides us, and very important for the digital journey. So as we move to the next slide, yes, so we come to some of the key use cases that this platform can enable. So I think Prashant can take a deep dive with some of the use cases.
Yeah, thank you very much. Thanks, Subrato, for detailed discussion and detailed architecture, detail provided to audience here. So I just take you to one of the use cases, and this is a very, very high value use cases for any kind of industry. Identify the machine anomaly or condition monitoring, or enable the predictive maintenance. So if you go to the next slide, please. And now, if you go to the machine condition monitoring, first you start with the what type of sensors you have to connect. So you have to connect different kind of sensors: energy meter, vibration sensor, flow meter, pressure transmitter, and some of the data already available in PLC. So edge device itself on a machine, you can install on a machine. You can connect this data over 4 to 20 milliampere. Then for status of the machine, you can connect the digital input output, and some sensors like pressure transmitter, flow meter. Now you can connect over 4 to 20 milliampere, and vibration meter or vibration sensors you can connect over Wi-Fi on this edge device. So all the type of data to identify machine mechanical behavior and mechanical electrical behavior is basically data will be ingested to the edge device. And edge device is, as Subrato mentioned, is vendor protocol agnostic, so you can connect on Modbus, OPC-DA, OPC-UA kind of protocols, which generally industry accept and available in industry to connect the devices. So once data is connected, using the telemetry services, data will be aggregated, normalized, filtered, and using the transformation layer, either writing the rule chain in the Node-RED, or writing some kind of calculation or KPI calculation. Okay, you can run on the device itself using the Python upon capability of edge management layer. And once data is transport to the data lake for kind of AIML, machine anomaly detection, and diagnostic to be run, or descriptive analytics on a dashboard actually. So this is a kind of architecture you can use for machine conditioning monitoring use case, where you can collect the sensor data, data ingestion, quality validation, normalization of data. You can display the KPI driven analytics, either descriptive or predictive, and run the machine anomaly detection algorithms on the edge AI itself, and identify the evolving fault on the machine. So this is how Edge 360 platform can transform or the data and use for the this particular use case. Just go to the next slide, and I want to show you that what we do and how our platform basically in the next slide can be useful for smart manufacturing or kind of smart water or smart building, because this platform is a generic platform, so you can utilize for any kind of industry now, where you can collect the data and different kind of use cases like quality analytics, predictive maintenance, operational intelligence, or in water, digital twin of water, wastewater treatment plant, or pump anomaly detection and diagnostic, or in a building where energy is a major cost burner, where you can use for the energy analytics, or providing the sensor data hub and providing the process awareness actually. So now question is, why CIMCON Digital? So we understand field of automation better than many of the player in this industry. We understand protocols, we understand challenges, connectivity with the legacy system, connectivity those assets. And so because we are doing this since last 30 plus years, so this is all knowledge we have embedded into our IoT Edge platform. So that's a key requirement to look into any IoT Edge platform, because ultimately IoT is all about scale, and transformation is also how quickly you can now how quickly or how accelerate your transformation journey, where Edge IoT platform is a very crucial role. And we believe always in a value for money, and customer success is our motto. And our solutions are already used by Fortune 500 companies to reduce the cost of operation, increase efficiency and productivity. So now, how we enable now system integrators and OEM of the world, how you can join us to make this digital transformation real. So we make it digital real, and how we enable you as a system integrator and OEM. So we provide, first of all, digital transformation experience as a service. So this particular engagement model we will help you to run the art of possible workshop along with your team and customer team, and help you to develop the business case for digital services. If you are OEM or system integrator, we provide a kit where you have a one edge device and couple of vibration sensors, and built with all the microservice library for smart manufacturing, smart water, or smart building. And you also can run or demonstrate your application, because we'll also provide cloud development and runtime for the 5 devices, or either we have a lot of pre-built application available on this layer, so which you can demonstrate to your customer quickly. And we not only provide this hardware and software, but we provide 15 hours of training from our certified engineer, and couple of hours, 20 hours of training of support from the application engineers and subject matter expert. So we will ensure that now you will be successful, and now customer success is a key. We also were available for the joint go-to-market plan, and if you are OEM, our layer is completely containerized. You can run your app with your IP on this environment. And if you are system integrator in a market and you're looking for the marketing support, we also have included some kind of digital marketing support, to create the market along with you actually. So with this, I would say we talked about many things, and I'm sure you have a couple of questions in your mind. So maybe Ankush, do you have any question on a chat window you would like to give it to me or Subrato?
Yep. Thank you so much for giving us such a great explanation about the Edge IoT platform. So the question, so one of the questions which I have received is that I saw Subrato talking about the applications, the Edge IoT applications that can be run, but they want to understand that in video analytics, what is the application. What is the application that can be run using video analytics in this platform? If Subrato can explain in details a little bit that what are the applications that can be run, and apart from video analytics, if there are anything, any case studies that he can, he can share in a little.
Yeah, thank you, Ankush. So yeah, so let me take up the video analytic case on the edge. So video analytics is a subject that can be applied to multiple scenarios when we're in a factory situation. Think, for example, there is a conveyor belt running and we want to automate that process of counting maybe cartons, bags. We want to make sure there is no theft or pilferage. We want to make sure that the belt is running in a condition, in a proper condition. And if there is some problem, we come to know on a proactive basis. So these are the things that can be detected by a video analytics application that has a camera, focused over a conveyor belt. That is one application. Then there are cases where we can monitor the external features of a machinery. Typical things like spillage of acids, oils that can cause accidents that can be caught much before it happens. Things like onset of corrosion on iron and steel exposed parts that can be done with analysis of the video patterns on images over a period of time. There are locations in the factory where it is not possible for human operators to approach and take a snapshot or picture. This is where you place a camera and you can analyze the change in surroundings. Then of course there are things like on safety part of it, you have your factory floor where you need some ambient lighting to be maintained, right? People coming in and going out, whether they need to be monitored on a regular basis. These all can be caught on the camera and it can be all done on the edge device. You don't need to burden the server backend with all the video processing. It is done on the edge device itself using intelligent algorithms. And the edge device just lets know the server, yes, say for example, on this conveyor belt, we have counted so many bags in a shift or in 1 hour, or this is the expected number of bags that we expected to count. Maybe 5 are missing, which could be a case of pilferage or theft. Say for example, on a particular machinery foundation, we found little bit of spillage. It could be acid, it could be some chemical. There need to be some follow-up action, and so on. So these are the typical use cases that we can expect on the factory floor. Then there are many others also. So I hope that answers the question in very brief.
Yes, absolutely. I think it answers the question. Thank you so much for explaining in details. Prashant, you can also there is a question which came in like, what are some of the other applications that we, as a system integrator, as an OEM, that we can work on in this industry? Because the engagement model which you have proposed is obviously a very lucrative one. So what are the industries that they can really apply this platform in?
So as I mentioned, this platform is a generic platform and built uh, for the manufacturing industry and utility and building in mind. Of course, that's a key area we are focusing. But otherwise, platform is very generic. You can connect any kind of IoT data on this platform, and platform is capable to accept custom protocol communication. Even though we have all type of possible communication protocol available for the manufacturing industry or the utility or building or water industry, you say BACnet or Modbus or OPC UA, OPC DA, Wi-Fi or Zigbee. So data collection. So once data is available, the question comes of transformation for any kind of application. So that's where Python comes in the role. So once data is available, kind of sensor data or real-time sensor analytics can be done, and transport layer will take care of transmitting those data on the edge management layer, and then data lake. So yeah, so you can select your use case. Now platform is now capable to run multiple use cases of any kind of industry.
Yes, thank you so much, Prashant, for giving the overview. So these were the two questions I had. If I would like to request the attendees that if you have any questions, please feel free to ask in the chat box, or you can also mail to us, as I mentioned before, at ankush.bose@simcondigital.com or contact@simcondigital.com. So this concludes the webinar for today. Thank you so much for attending the webinar. As I mentioned before, we have our offices in Boston, Massachusetts, and our office in head office in India is in Ahmedabad, India. So you can also follow our social media pages on LinkedIn, Twitter, Facebook. We are quite active there, and you can also mail us if you have any queries. Thank you so much for attending the webinar. Hope you have a good day, and yes.
Thank you very much. Thanks all attendees for your time. Thank you very much.